Okay, today we talked about parallel and perpendicular lines. A couple of real quick definitions on those. Parallel lines. Let me just increase my pen here just a little bit. So parallel. Yeah, a little too big. Hold on. Let's go right in the happy medium. There we go. Parallel lines are lines that do not intersect. So if I was to draw a graph of parallel lines, here's my coordinate, Cartesian coordinate plane. I might have a line that goes like this. Parallel lines would be another one that goes exactly in the same direction. And what we find out is when we map these, let's say we got two coordinates here and two coordinates here. And just to give you a real brief synopsis, when we look at rise over run, let me change my pen color here. So we go rise over run on this line, it's the same exact rise over run on this line. So in essence, the idea is that slopes of parallel lines are equal. So on your worksheet, sections that say, the directions say, find the equation of a line passing through the given point and parallel to the given equation. Write your answers in slope-intercept form. Let me do number 2 real quick. So number 2 says, going through -1, 6, and it's parallel to this equation, which is y equals 1/2 x minus 6. So I look at the equation of the line that it's parallel to, which is this one, and I say, okay, if I know the slopes of parallel lines are equal, all I got to do is find the slope of this line. This is already in slope-intercept form, so I know that the slope is 1/2 according to this line equation right here. So if the slope is 1/2 for this equation, the slope of the line I'm trying to find is also 1/2 because I know that slopes of parallel lines are equal. So using that 1/2, I now use the y minus y1 equals m times x minus x1 point slope form to get my equation of the line in slope-intercept form using this point right here, okay? So here we go. I got y minus, here's y1, 6, equals m, well I know m is 1/2 times x minus -1. So x minus -1 is x minus 1. So I've got y minus 6 equals 1/2 x plus 1. Distribute the 1/2 over to the x as well to the 1. And then I will give y minus 6 equals 1/2 x plus 1. So I'm going to go ahead and distribute. So that gives me y minus 6 equals 1/2 x plus 1/2. Still not done yet. I got to get the minus 6 out of there. So I'm going to add 6 to both sides, plus 6 plus 6. So therefore, I am left with y equals 1/2 x plus 6 and 1/2. And I can keep it just like that. It's in slope-intercept form, and I can go back and look at the original equation and find out that the slopes are the same. They're both 1/2, so I'm good to go there. Now, it may throw you for, say, number 5 from the worksheet. Number 5, a little more work. I've got through 5, -2, so I have a point that's on the line I'm trying to find. And this one says parallel to, and it gives you 5x plus 6y equals 12, which is in standard form, okay? I have no idea what the slope is on this particular equation until I put this in slope-intercept form. So how do I do that? Well, I subtract 5x from both sides. I can't combine those, so I got 6y equals minus 5x plus 12. Now I got to divide by 6. So I divide everything by 6. Y equals -5/6 x plus 12 divided by 6 is 2. Didn't really need the the y-intercept there, because all I needed from this particular one was the slope, which is negative 5, 6. So I've got the point. Let me switch slides here, or get a new slide. And my slope is negative 5, 6. Okay, so now I am going to take y minus y1 equals x m times x. Oh, hang on one second. Let me erase something here. Equals, let's try this again, m times x minus x1. I got my slope at a negative 5, 6 over 6. So I've got my points. So here I go. Here's y1. Here's x1. Let's plug and chug. Y minus negative 2 equals negative 5, 6, x minus 5. Okay, so let's see what that looks like. So this is going to become y plus 2. This is going to be negative 5, 6, x plus, because I have negative 5x, 5 over 6 times x. Negative 5 over 6 times negative 5 creates the positive. We'll just keep this as 25 over 6, ugly fraction. Got to subtract 2, subtract 2. So my final is y equals negative 5, 6x. 25 over 6 is roughly 4 and a sixth. Minus 2 gives me 2 and 1/6. There's my answer right there. It's in slope-intercept form, and I'm good to go. All right, so that's parallel lines. About perpendicular lines. Perpendicular lines are formed when two lines intersect, but they intersect. Let's say this is my first line. They intersect at a 90-degree angle. So let's say that's my second line. This is a 90-degree angle. Okay, so that's what perpendicular lines are. And if I was to extend this and start putting points on these lines, I would notice that my slope, as I count rise over run here and then rise over run here, my slopes are what are called negative reciprocals. Which means if the slope of this line, let me grab my pointer, I'll show you my pointer here. The slope of that line right there is negative, 2/5, let's say. I look at this line right now, and I know that the slope of this one, considering they're perpendicular, the slope is negative reciprocal. So what does that mean? Well, it means I flip the fractions. So I go 5 over 2. And then I change the sign. So in this particular case, it's negative. So now it becomes, I'll put it here, but then I'll erase it. This becomes positive 5 over 2. So once again, flip the fraction, right? So 2 goes below, 5 goes above, and then whatever the sign is, just change it, flip it to the other sign. So if this was a positive 2/5, this would be a negative 5/2, but it isn't. It's a negative 2/5, positive 5/2. That's what negative reciprocals are all about. Let's do let's look at 8. 8 says through negative 2, negative 1, and it's perpendicular to y equals negative 1 over 5x plus 1. So I immediately look at my slope on this one as negative 1/5. I know that it's perpendicular, so the slope that I'm looking for on my line is 5 over 1 flipped. So I got 5 over 1. I notice that it's a negative, so now this becomes positive. So technically the slope over here is just positive 5. That's what 5 over 1 is, positive 5. So here we go, y minus negative 1, there's y1 right there, equals m, which is 5, times x minus negative 2. And there's x1. So let's work through this. Y plus 1 equals 5 times x plus 2. Y plus 1 equals 5x, right? Distributive property. Plus 10. I subtract 1 from both sides. So now I get y equals 5x plus 9. There it is. There's my equation. Threw a little something different in there for you. The last chunk, 11 through 14, I basically tell you, I give you points on line 1 and points on line 2. And the question basically says, determine whether lines 1 and 2 are parallel, perpendicular, or neither. Well, again, parallel lines, let me just make some notes up here. Parallel lines have equal slopes. So if the slopes are the same, then the lines must be parallel. If they're perpendicular, then they would be negative reciprocals of each other. And if they're not either equal or negative reciprocals, then obviously they're neither. Let's look at 12. So what I got 3, 2. So line 1 has 3, 2, and negative 1, negative 2 on the line. Line 2 has 2, 0, and 3, negative 1. And all I got to do is find the slopes on these lines. And you notice or you'll know from previous sections, how do you find slope when you get 2 points? Well, that's y2 minus y1 all over x2 minus x1. So I'm ready to do that for line 1. I have y2 negative 2 minus 2 over negative 1 minus 3. So I have negative 2 minus 2 is negative 4. Negative 1 minus 3 is negative 4, which all ends up being positive 1. Let's do line 2 now. So I have negative 1 minus 0 all over 3 minus 2. Negative 1 minus 0 is negative 1. 3 minus 2 is 1. Negative 1 over 1 is negative 1. So line 1 is 1. Line 2 is negative 1. And I look at these and I go, what are these? They're not equal, definitely not equal, but they are negative reciprocals of each other. So therefore, these two lines are perpendicular. Lost space. Hopefully that helps.